The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets, always on trend, always on sale. Plan your trip at Tanger.com.
You're listening to the Archaeology Podcast Network.
Hello and welcome to the Archaeotech Podcast, episode 182. I'm your host, Chris Webster, with my co-host, Paul Zimmerman. Today we talk about a new software used for measuring and analyzing lithic artifacts. Let's get to it. Welcome to the show, everybody. Paul, how's it going?
It's going pretty good. I'm scrambling millions of different emails and phone calls and such because in 2 days, today is Friday. In 3 days, I'm heading off to Saudi Arabia on another project. And
nice.
Yeah, there's a lot of moving parts that have to be ironed out, a lot of permits and medical reports and insurance and this and that. And it's turning out to be a lot of work and preparation, but I'm looking forward to it. It's going to be a fun project.
Awesome.
How are you doing? Where are you now?
Yeah, good. We're up in Port Townsend, Washington, we're just south of Port Townsend, Washington, which is over on the Olympic Peninsula. In fact, this afternoon, we're going on a hike in the Olympic National Park, which is, real close by here. And it's just a really cool area with a lot of history. There's museums all over Port Townsend, and we're checking some of those out this weekend as well, because here in the United States, it's actually a 3-day weekend, and I completely forgot until somebody told me yesterday, because Monday is the brand new federal holiday of Juneteenth, and I completely forgot about that.
Yep.
So, yeah, we got some good time for doing some things while we're here. And on a more tech front, just a quick Starlink update. Man, this thing has just been killing it lately. The last 3 places we've been, I don't need to switch my service to where we're at because we have the new portability feature turned on. But if you do switch your service address, you get more prioritized, right? You don't get interrupted if there's too many people in your cell. But each of the last 3 places we've been able to easily pop in to the cell and have 0 interruptions in service. And I just did a speed test the other day. Like, my wife was on a Zoom call at the time, and I'm pretty sure something was streaming on the TV while I did the speed test. And it was still like 290 down, like 50 up. Wow. I was like, holy crap, this thing it's just really killing it. And as we're recording right now, I got the YouTube notification right before we started that there's another Starlink mission heading up into space as we speak. They're going to be lifting off soon, I think, if they haven't done it already. So they're launching, several rockets a month with more satellites on it, and it's just getting literally better and better and better every single month. I don't know how Elon Musk just keeps his stuff going. I was also reading an article just last night about like the electric car manufacturers, like Rivian was like number 2 in, hopeful possibilities for electric trucks coming out. And because their trucks are just super cool. They look like trucks, but they look futuristic at the same time. And they just announced a massive delay because of supply chain and funding issues. And everybody's kind of shocked because like Ford and Amazon are huge investors in Rivian. It's crazy. And yet Tesla just keeps trundling along with Starlink and all of his other endeavors. They just seem to be successful despite what you might think about Elon Musk. All his stuff's working. I don't know what to say about that.
Those Rivians, actually, I was surprised because I'd heard about the supply chain issues that they were having. And in the last week, I've seen 2 of them as I drive around the New York area. So on the road. So they actually exist. I thought they were still vaporware, but no, they're out there. And they are cool looking, but geez, they're pricey.
Oh, I know. They're super expensive. And that makes the one I saw all that much more heartbreaking because the only one I've seen in the wild was in Seattle. I guess it was probably about a month ago. I was in the Seattle area driving up I-405, and I saw one on the back of a flatbed pickup because it had been hit from behind. The left rear quarter panel was just crunched. I was like, where do you even take that? Because that's been one of their issues, is actually rolling out their vehicles in places where they can service their vehicles easily, right? So they're trying not to roll vehicles out before they have services available. And that was one of the things that article I was reading mentioned that Rivian hasn't really been able to do is, Tesla had the ability because not only did he just inject a lot of his own cash into it, but they got a lot of massive investment, and they had the ability to do the grow first, profit later model, which is difficult to do in car manufacturing. Easier to do in like some models, but in car manufacturing, grow first means you have, literally billions of dollars to throw at this thing before you can actually make a return and hope that you make a return. So yeah, they were able to rapidly expand and put up dealerships and service centers and all kinds of stuff. And that's what's keeping them going. So anyway,
speaking of seeing something in the wild, the other day, getting stuff to go in the field, I was over at the Target and I saw your wife, Rachel, and I went to go, "Hey, Rachel." And I realized that no, she probably was on the other coast and this was just her doppelganger. So I'm really glad I didn't embarrass myself calling out to a complete stranger in the store.
Nice. I'll have to tell her that. She does have family up in upstate New York, so maybe a slightly close genetic copy was roaming around that area.
Was roaming around the streets of Danbury.
That's right. Oh, man. All right. Well, today's episode, as we mentioned in the introduction, is about an article. I was just trolling some stuff, looking for this, and I don't know. Actually, it's been just such a busy couple of weeks for me too, and I didn't really have anything for this episode. Honestly, leading all the way up to the recording yesterday, and then we kind of transitioned. But I found this article in PLOS One that came out literally this week.
Literally yesterday, as of the day that we're recording. So, whereas you didn't have much time to do a lot of research, I've had even less. And so, as will become abundantly clear, I've only been able to quickly skim this article, but it seems really, really cool.
Yeah, indeed. And let's get into it then. So the article, again, is from PLOS One, so it's open access. You can check out the article link in the show notes. And also, this is promoting new software that the authors of this article have actually put together. And the link to that software is also in the show notes. It's from SourceForge that you can get it. And the user manual, everything is in there, according to them. I didn't bother clicking on that, to be honest, because one of the other requirements before you get too excited is a Windows machine running Windows 10 or higher. So I'm on a Mac and can actually try it out, but it sounds really cool. And I actually don't have any 3D scans of artifacts either, which you kind of need. So, but we'll get into that.
Yeah.
So this journal article, again, like Paul said, written June, or at least published on June 16th by, I don't know how to pronounce this person's first name, Lior Grosjean, I think, and others, a number of people on this thing, but they're all basically from the, where is it? The Computational Archaeology Laboratory of the Hebrew University of Jerusalem. And it sounds like these guys have been putting together, they say in the article here that they've been seeking technological innovations to archaeological questions for over a decade. And they've been looking at a number of different things to, like I said, essentially use technology in various ways, from software programs to hardware, to do and to do different things better in archaeology, right? And I always appreciate that kind of a thing. What they're addressing in this article is essentially the problem of artifact analysis, and more specifically lithic analysis, when you're talking about, say, projectile points and maybe utilized flakes and stuff like that, but tools, lithic tools and points and stuff. And it really is something that I have thought about actually pretty extensively. It's the problem of measurement, right? You got one person sitting either in it's especially worse out here in the American West, because we typically on field survey don't collect anything, right? Unless it's really special and we get permission from the agency that we're working for, say, hey, we found something super cool. Here's a picture. Can we collect it? Like a Clovis point is an obvious collection point, but other stuff could be as well if you think it's rare enough or a good enough example of something that should be collected. But typically it's no collect, and that's what it says in your permit. So since it's no collect, we're taking attribute data in the field. And, honestly, we take like 3 measurements in the field typically of a projectile point: length, width, and thickness. And even that is just like setting it on your ruler or on your scale bar or something like that, and just kind of estimating it. But we estimate like to the nearest millimeter. And if it's kind of a thicker point and you've got some parallax error going on, like you're leaning one way or the other, you might be off by a few millimeters. And that's how you're measuring that for basically forever. like those are going to become the measurements of that point. And that, along with your photographs, are going to basically influence interpretation for who knows how long, right? Possibly years to come for that particular artifact, because no one may ever see that again. And it's likely that no one will ever see that again. So those errors in recording could be significant if, depending on who's doing it, and we're basing a lot of interpretation and analysis on those measurements.
This article is focused on lithics, and you were just talking about an example with lithics, but I see the same thing all the time with ceramics. You take a pot sherd, and hopefully a nice good rim sherd, 20% or more of the rim, but you hand that same rim sherd to two different people, and you're going to end up with two different drawings.
Right. Right.
That there will be differences between them. We tried to use the same methodologies and so that the differences between one person drawing and another person drawing aren't drastic, but they're still there. And typically you don't then save all those barely diagnostic rim sherds. You throw them back out in the pottery dump at the end. And this is talking from an excavation. But in the same way that your 3 measurements and photograph that you took of that object in the field are going to be the only record of it, these pottery profile drawings that you're doing are going to be the only record of it. And so you're trying to reduce that variability, trying to make things that are essentially metric be very much more reproducible and very much more accurate is really good. So that's where I'm excited about this article.
Yeah, indeed. And finding good ways to make these measurements, 3D scans are one thing, but then you need to actually analyze the 3D scans. And that's where the software comes in, right? And just to back up on the backstory just a little bit, and they're setting the stage in the beginning of the article, right? And we've kind of alluded to this, but more specifically, they say, in reference to the importance of accurate measurements, is the variability of attributes, and this is almost exactly from the article here, of artifacts over time or space is usually interpreted as indicating technological, cultural, or functional distinction and transition, while homogeneity, so, similarities, is interpreted as indicating continuity or influence. So we base interpretation of cultural interpretation a lot on, what do these artifacts, like accurate measurements of the artifacts, and then comparison of those artifact assemblages either through time in the same site or across space with other sites, right? And then also through time. There's a lot of ways that we measure that, I guess, comparison between those artifacts between different cultures. I mean, that's the bread and butter of North American prehistoric archaeology, because almost nothing else persists, right? I mean, on the East Coast and some areas in the West, you'll get pottery, like you said. But to be honest, almost everywhere, lithics are a standard. Pottery is a variable that you may get. Groundstone is a variable that you may get. And other, other things that, could pop up in the archaeological record, and they're extremely valuable information-wise when you get them. But lithics are a constant. I feel like they just persist because they're rocks and they're everywhere. So accurately being able to, to measure these things. Now, here's where a little bit of commentary is going to come in. That being said, if they're, what they're saying, actually, if you really interpret this, they're saying that we haven't had accurate measurements basically forever, right? Because we haven't been able to do it down to, the sub-millimeter level with a high-quality 3D scan. And I'm wondering, with the variability in just a stone to begin with and how that stuff flakes, and you could have an expert flint knapper working with the best material and have them make 10 of the same thing. And while they may look the same if you're just setting them on a table, there is going to be some small variations in these just because of the way stone fractures and the way things work. And I'm wondering if that variability, a millimeter or two either way, in measuring and flake densities and stuff like that, if you're sketching, does that matter? That's the biggest question I would ask. They're hyper accurate with this software, but I'm like, but yeah, it's kind of a fuzzy thing to begin with. Does it matter? Is all our interpretations basically wrong? Or if we were able to actually reanalyze everything we've done for the last 50 years, would we come up with wildly different theories? That's kind of what I'm wondering with this. I mean, I'm not downplaying the need for 3D scans and more accurate data measuring, but I'm like, is everything we've done really kind of crap, or is it, close enough? You know what I mean?
Yeah, I would guess, and I'm not a lithicist, but I would guess it's probably close enough. Just like you're kind of guessing or strongly implying that it's probably close enough. That said, though, if this can be done again to systematize and to standardize, to reduce the variability of the measuring as opposed to the variability in the creation of the object. That's probably a good thing, even if it's being measured to a precision that's greater than what's warranted.
Right.
If it's adding a whole lot of extra time and complexity into the workflow to measure things at a scale, at a precision that is meaningless, then why bother?
Yeah.
And I'm going to trust that that's not what they're doing here.
Indeed.
But I suppose there is that problem. I think about that all the time. I always talk about total station surveying, but I can measure things down to the millimeter. But depending, where exactly on the feature or on the soil surface you're taking that point elevation, or if you have the pointy tip on the prism pole or the flat tip on the prism pole. That millimeter of precision from the total station might be more precise, and probably is more precise than the variability you get just depending on where the prism pole holder decides to put the rod.
Yeah, exactly.
Doesn't mean I'm going to get rid of total station surveying, though.
No, of course not. But you have to just take into account that, this is, we do want to use the most accurate recording methods possible, within the ease and quickness of use, because budgets are always a concern. We don't have years to do this, recording and analysis. We want to get it done quickly but efficiently. So, and that's where I think this software really kind of turns a corner with some of the other things that are possibly comparable, is the ease of use of it. So let's get into a little more about the software on the other side of the break.
Chicken tacos should only be trusted to chicken professionals.
That's where we come in. Introducing Zaxby's new chicken finger tacos. One comes with pico de gallo and creamy chipotle ranch. And the other comes with bacon, lettuce, tomato, and avocado ranch. Chicken experts since 1990. Chicken taco experts since now. Order yours today in the Zax Rewards app. Woo, saucy! Zaxby's.
Welcome back to the Archaeotech Podcast, episode 182, and we're talking about an article in PLOS ONE. Artifact 3D is the name of the software that they're promoting here, basically. And let's talk about a little bit about, essentially the background of the software and what they expect to do with it. So the people in the article, the authors, the study authors, they say they've been using 3D modeling technology and computational analytical methods to describe and analyze lithic and other artifacts, right? And people have actually been doing this for, I would say, a number of years at this point. 3D analyzing of artifacts, like 3D scanning of artifacts, is, again, like I mentioned in the case of CRM, not exactly standard unless you're doing excavation and you can take that stuff back to the lab and then do it. But then even then, I don't think, just from what I've heard through the grapevine, that most firms are doing regular 3D scanning of artifacts with high resolution 3D scanners in the lab, right?
Right.
And I don't know exactly how long that takes for a lithic artifact from setup in the scanner to tear down and setting up another one. I'm not really sure how long that process takes. I don't get that it's that long of a process. It might just depend on the type of artifact you have and how you position it within the scanner. Because I would assume, because it's got to be held up by something, it's not just floating in space. You might have to scan it twice to get most of the artifact, and then also get the portion that you were supporting it by with some sort of gum or something like that, that sticky, what is that called, you know what I'm talking about, not like gum for real. Yeah, something like that, right? Actually just like using gum, although that would probably work. But you know what I mean. So some sort of holder, and then you got to scan that part too, because it's invariably probably concealing something that needs to be scanned. So I don't know how long that takes, and if it's worth it for CRM firms to even do that, because you could potentially find, hundreds, if not thousands of lithics. But does it take longer to sit there and take manual measurements and then type them into a spreadsheet with the possibility that those measurements could be inaccurate? I don't know. I don't know what the deal is there.
I don't know. I think that this is one of the directions that our field is going, though. People have been doing, many different kinds of 3D scanning, photogrammetry, which I've been playing with a lot lately, but then also using dedicated 3D scanners of various kinds. And the prices have been going down. The time that it takes to process it has been going down. The expense of the equipment is, I just said price, didn't I? Me repeating myself is going up. But so this is increasingly becoming parts of people's toolboxes. So I'm looking at the article here, and the part that's unsaid is what you're asking here about the initial scanning of the objects. Mm-hmm. So to speed things up, you have to be able to scan them faster than you would be able to photograph and draw and describe. But then for the measurement, that also has to be faster and more accurate than the taken from the 3D scans. Has to be faster and more accurate than what you would do with traditional means. So there are a lot of places where this might actually be a slower process, even if it is more accurate, more precise in the end. And then it becomes a question of the benefits and the trade-offs that you make for that. When we were in the field, somebody had posted, I think on Twitter, a system that they were working on that was doing 8 potsherds at a time, hung up from like a clothes dryer.
Oh wow!
Wire hanger arrangement, and our ceramicist Sada was just the gaga over. She's like, oh my goodness, it's so much awesome. Easier because they could scan those 8 potsherds. Now potsherds are less complicated typically than one of these hand axes, for example, that they're showing in this article. But if that's true, that they can do 8 at a time and get good full 3D scans, that they could then take those measurements, and that doesn't have to be done real time. I mean, that's another thing, is that you can, if you have the 3D scan and it's good enough, you can do the measurements not in the field. You don't need the object anymore to take those measurements. So it allows you then to offload that work to somebody that's not on site, or to take those scans with you and do them when you're no longer actively, spending a zillion hours a day in the field.
Right. And what you said too about speed and efficiency, about, I was just talking about the scans as far as measurement, but you mentioned photographing and illustration as well. And that is a really good point, because, we always take photographs of artifacts for documentation purposes, reporting, stuff like that. And often we do illustrate them as well, because the photographs don't always obviously show you where all the flake scars are, and that is the main purpose of illustration, is to basically show you where the flake scars are and how they're oriented, right? Because flake scars tell a lot about how an artifact was manufactured, and its manufacturing tells you a lot about the people who did it and their skill level in doing that. So when you factor in photograph and illustration, and the fact that this software can actually do that as well, you can use the artifacts for illustrative purposes from the software and export that straight as something you can use in a report. But what's also cool is you can take according to this article, you can decide, do like a cross section and do that slice wherever you want and show that cross section, and then the measurements of that cross section in what was also really cool, 2D or 3D measurements. And 2D would be, if you've got like a concave shape to a lithic. 2D would just be from side to side. It would just be the straight linear measurement from side to side. And 3D would, of course, take the shape into account. And that's really cool, too. I don't think really anybody is doing those kinds of measurements on a regular basis. They might do it if they're doing a special study on something, but on like a regular basis, who the hell is doing that kind of measurement, right? And maybe that sort of measurement could actually tell us something once we do a comparative analysis across a large assemblage that we didn't even know that we were looking for, right? It might be more diagnostic. It might be, more, I don't know, just telling of something we don't even really understand yet. So there's the way 3D scans work, there's points all over this thing, and it's using, depending on the scanner, it's literally taking millions of points and putting them all over this, maybe not millions on a projectile point, but lots of points. And they're using all of those attribute data, and they've put together all of these calculations and stuff. You don't have to write any scripts. You don't have to do anything. It's putting all of that into this software as one complete package, and then, spitting out these measurements that, like I said, we wouldn't have had otherwise. So there's a lot of value in that.
Yeah, I did think it was interesting, the slices through the artifacts. It's not a new idea. to do something like this? I mean, I did slices.
Sure.
I reconstructed for my MA back in '98 part of the site of Ur, and then did slices to get the relative elevations of the different tombs that were there. And that was all in CAD software. But as I just remembered that as I was going to say what the other thing is reminded me of, which is, hey, so I did that a long time ago. No, what I was
OG
gonna say
slicer.
was that Slice, actually, that's GPR Slice. We were just using that on a project I was working on a couple days ago, doing GPR of a parking lot in Brooklyn to see where the original house foundations were and where their cistern and privy were. But GPR Slice is very well-known software that anybody that's using GPR is probably using, and you can take slices, hence the name, through the earth from your GPR imaging. But I was thinking a lot of, when I was reading this in the article, of medical uses, medical tomography, right? So we're used to seeing CAT scans, MRIs, where they take slices through somebody's head so that they can see a tumor or something. Yeah. And it's obvious application of this. And like you're saying, it might be extremely useful. Not quite sure yet, but I do like that, like so many things, it's not just an archaeology thing, that it's a set of techniques, a set of visualizations, a set of probably software and algorithms that could be adapted from other places, like from construction or medical.
Absolutely. And I think we've kind of alluded to this, but I've got to say specifically, in case you're interested in this software, that this software is not the engine that they're using to actually do the scans. I don't know if we actually specifically said that. I want everybody to get confused. This is not 3D scanning software. You can't hook it up to your scanner if you have one and then pull the stuff straight in. But it will accept what I saw were a number of common 3D scan formats. So you have to 3D scan these in some other way. And they did actually say that, if you don't have like a high resolution optical scanner just lying around your house or your lab, and you can't do that, they have been able to get decent data from photogrammetric scans. So, I doubt you get too good a data from something like, what is that? There's a couple of like free 3D apps, what I'm talking about, for like smartphone, where you can just take a series of pictures and then stitch it together, a kind of a fuzzy 3D rendering. I don't know if something like that would work so well. I mean, it might if you got good lighting conditions and you're steady with the camera and the object. Who knows? I mean, data stuff like that is typically, garbage in, garbage out kind of thing, or good in, good out. Yeah, I mean, I think some sort of 3D photogrammetric scans of something, it sounds like they're getting decent data off of that. Go ahead.
Yeah, so those programs for your phone, what they tend to do is not make that complex of a model, but then the realism comes from the texture mapping. And so you don't necessarily have to show every wrinkle in somebody's skin if you scanned a face, because the dark spots that from the photo part of the scan are going to give the impression of the wrinkles there. And I don't think that would work, or I'm sure it would work, but I don't think it would work with the accuracy that you're trying to use this software for, unless you have a really highly detailed, accurate scan initially, not one of these phone good enough scans that you then texture map, because the examples that they show, none of them have texture maps. And yet you can see the texture of the stone because they're such highly detailed. There's so many thousands or tens of thousands of points on these objects. There's such highly detailed 3D scans to start with. I would be curious to see what would happen if they were to then apply the texture map on top of these, just for visual purposes, not for measurements, because I'll bet that these things look stunning.
Yeah. And I mean, one of the reasons I was thinking about, like a phone app or something like that is, again, the case where you're not doing collection, right? So if you can get a good enough scan, and I'm wondering more specifically about something like the iPhone 12, because the iPhone 12 has the upgraded camera system. So not only are they higher resolution cameras, but it's also got, the like point mapping for the AR system inside the camera. So it has the ability, if turned on through an application, to actually, reach out and digitally map the surface of something. Now, I don't know what resolution it's doing that with. And if you were able to combine that feature with digital scanning software, you might actually be able to get some pretty decent scans out in the field. Just using your phone, if you've got the right material or the right hardware. So that would be cool.
Yeah, no, I've got the iPhone 12, and I got it in part because of that LiDAR scanner on the back.
Yeah.
And I've used it, and it works fine on the scale of rooms. And I have scanned some smaller objects with it, but those scans, the LiDAR isn't fine-grained enough for use on an object, really. It relies, like I was just saying, on the texture mapping to give it a good sense of realism. On a room scale, it does work, and I do think that this is actually a potentially useful tool, especially for people that are doing standing structures. So somebody that's doing architectural history, for example, it's not a replacement for a full measurement and, elevation plans and whatnot of the building, but it definitely is good enough to replace snapshots, which is usually part of somebody's workflow.
Yeah. I'm looking at, a lot of the 3D scanners currently available that mention the use of the LiDAR functionality, and almost all of it is room scale. At least in their representations here. There's one called Smart 3D Scan that actually shows smaller objects. I might have to try that out. Anyway, lots of cool stuff in there. Let's take a break and come back and wrap up this discussion about the new software 3D Artifact, Artifact 3D. 3D Artifact 3D. Who knows? You'll find it either way. We'll be back in a minute.
The Labor Day weekend sale is on at Tanger Outlets. Score up to 70% off at top brands like Nike Factory Store, Crocs, J. Crew Factory, Gap Outlet, and so many more. Refresh your wardrobe with the latest arrivals for less from all your favorite brands this Labor Day weekend. Tanger Outlets, always on trend, always on sale. Plan your trip at Tanger.com.
Welcome back to the third and final segment of the Archaeotech podcast, episode 182. And we're talking about this new software, Artifact 3D, from an article in PLOS ONE written by the people who created the software. And they have actually written about this before, they say, as they're incrementally, developing features of the software. But now they're calling this essentially a full package. Like it's ready to go. It is free for academic use. I don't know if we mentioned that. And I don't know how they prove academic use, if you can just go there and download it, or if you have to demonstrate an EDU address or something like that. I'm not really sure. But the actual text says free for academic use. So I think if you're listening to this, you can probably check it out. The other thing that I think is interesting about this, and we could get more into the nuts and bolts on, what this is doing and how it's doing it, but it's doing a lot of things. Just keep that in mind. And when you think about something like that, especially with software, you're probably thinking, okay, yeah, but like, what do I need to know to be able to use this thing? How complicated is this? And to be honest, it sounds like the interface has been designed in order to be as simple as possible. A good graphic user interface, a GUI, they call it. Everybody calls it a GUI. It's supposed to be just like incredibly intuitive. And that has been obviously with newer technologies, especially in use in archaeology. A lot of times they aren't polished enough to have that, ease of use factor. You have to have a high knowledge in some sort of scripting or programming or, some other technologies in order to be able to actually use something. Paul's talking about total stations earlier. I mean, I remember seeing people, for some reason, I was always kind of good at it, not like tooting my own horn here, but just like leveling the total station always seemed to be a problem for a lot of people. With the laser level, even, it was just like impossible. They're just like spending an hour and a half trying to get the damn thing level. It's just moving it around. It's just get it level. But anyway, this sounds like they've designed it to where you don't need to have a high skill level in actually this kind of software. You do obviously need to know something about your 3D scans or have somebody else do it. But then once you drop in the 3D scans, which you can do one at a time, or you can do an entire assemblage in a folder all at once and just let it crunch in the background while you're doing other stuff. They specifically say that. Then you can come back and do your analysis. And it's really just sounds like it's push button analysis. I want to see this. I want to see this. I want to see this. And then, export those results en masse.
Yeah. The analysis is interesting. I don't know that we mentioned it yet, but we have said that they're looking at lithics of various kinds. And this software is not a general purpose 3D artifact measuring software. It's really geared towards analyzing lithics, and not just little flakes, but entire tools. So, take that Both as, maybe a point of caution. You're not going to be able to use this for any other kind of artifact, probably. But also, having a very specialized tool like this does then allow you to simplify it. If you're only going to take 12 kinds of measurements off of a particular class of artifacts, you don't have to build in every other possibility. You don't have to, you can have a number of presets that are going to work 90% of the time instead of having everything be fully customizable and tweakable so that you could use it on not just the one that the artifact class that you've designed it for, but also anything else anybody could throw at it. So actually, I think that's good design, is to simplify and not make a fully general purpose tool if it's going to overly complicate things. And it looks like they did a good job, at least. Also, I haven't used it yet. I don't have any 3D scans of lithics around that I could probably test. Maybe I could download one from Thingiverse, because I know I printed out a 3D model of an Acheulean, not an Acheulean, of a Clovis point once. So you can probably find some online.
And I think possibly the what is it, Sketchfab? I think you could possibly download from Virtual Curation Laboratories website. Yeah, because the VCU has, with Bernard over there, the Virtual Curation Laboratory, they're always publishing stuff that they scan, and they scan literally everything, including themselves. If you ever see Bernard from VCU at a conference, he likely has a plastic business card that has his 3D scanned face on it. And that's pretty cool. And like little statues of himself. It's fun. They scan everything. So you're right. If you want to try this out, you probably can get pretty good high quality 3D scans from a number of places on the web. So that is really cool. And one thing, I want to read this paragraph that was later on in the conclusions. They say the Artifact 3D Toolkit encompasses the entire workflow of artifact processing, analysis, and documentation and publication. And then they have a sentence that says, once users acquire 3D scans, so not the entire workflow, you still have to acquire 3D scans. But the software then processes these 3D models, positions them consistently, which is important, based on their intrinsic geometric properties, and generates views, measurements, and sections that have been selected algorithmically without user input, bias, or interpretation. This unbiased system of object manipulation and orientation forms the basis for a series of subsequent measurements and analysis that can quantify any aspect of the artifact's morphology. So consistency is the thing they're really going for here. And consistency allows you to do, really good analysis that is unbiased.
Yeah, so I think it's interesting that they skip over that first bit about how you acquire the scan, and we just suggested that you could download ones from the internet to test, and you suggested Sketchfab, I suggested Thingiverse, and this is actually something else that I kind of like about this article, is that we've seen a lot of discussion about how to make 3D scans. I've got a whole bunch of articles I've been reading and different methodologies, and basically it's just being used as kind of a primary documentation, like a photograph. And that's as far as it's going. It's being used as an educational tool so you could show people and they can kind of play with it online without having to have the real object in front of them. Those are valuable uses, but they always felt a little lacking to me. And this article here is actually pushing it through the other end of it. Say, it's not good enough just to have that scan. Here's something real. Not that the other things aren't real, but here's something very rigorously applied to the sciences in our field that you can do with that scan. And so, I hadn't really realized, but that I had a sense as I was looking at this of, finally. Now we can know it becomes a real usable tool in the toolbox. It's not just kind of a whiz bang thing so that you can show off artifacts to other people.
Exactly. And you're right. That's often what 3D scans are used for, right? Just to show off and say, look at this is super cool. But unless you're doing something with that data, like you said, it's like, what's the point? And the fact that this thing can crunch and compare and do it all in one package is kind of the dream, right? Because some of these technologies, while interesting and effective, are tedious, right? They're still tedious. And this thing, doing the all-in-one solution, I almost call it like the Apple model, right? Because that's always been Apple's thing, is let's provide a device that does everything. That's what they're trying to do here. And I totally appreciate that. And they're trying to do it in a way that is actually easier for people to use. Now, I think the only, the real knowledge you need to have is you need to understand lithic analysis. Otherwise, you're not going to understand what it's showing you. But I think from the sounds of the article, again, I haven't used it either, but from the sounds of the article and some of the images they've shown, it sounds like if you understand lithic analysis already and you know how to do all that stuff, then what the thing is telling you is going to make sense to you. It's going to be logical. So it noted that it's, if your 3D scans are good enough, it can identify and illustrate lithic scars as well, like the flake scars we were talking about. That's really cool. I don't know of software in the past that's really been able to do that. I mean, 3D scanning software can obviously show you those really closely, but to actually map, identify, and analyze those lithic scars, I'm not sure if anything else really does that I'm aware of that we've at least talked about. So that's pretty neat.
I'm not aware of anything either.
Yeah. And I do know somewhere near the end in the conclusions, I think they're just talking about how awesome this is and how it just does everything. And then they have a little cover their ass moment where they say, however, we don't yet recommend discarding your pen and paper, for illustration, but I think they kind of do recommend that. They're just afraid to say it.
Well, we don't have to go into it now, but there's, we've talked about this before, that I think that even if you do have scans, photographs, and so on, there is something very important to drawing, because it is inherently mediated by your experience as a specialist, right? And so you see things and assign various importance to things that the camera has no knowledge of.
Right. While I agree with that right now, I think we are leading to the point with high quality, easy to achieve 3D scans. So as that 3D scanning technology comes down in price and ease of use, I think those high, like sub-millimeter resolution scans, I think that when those come down, combining like these guys do, the algorithmic nature of it, so and the computational AI of being able to do that interpretation, right? Because we've had scans for a long time, and we have scans now that can get those micro flake fractures that you can't even see with your naked eye, right? If you put it in the right environment and you scan these things, the scanner will see it, but it's dumb. It doesn't know what it's looking at, right? It doesn't understand that, oh, this is actually important. This is edgeware, and you missed it, but I saw it, but I don't know it's edgeware because you haven't told me it is. But with these computational, algorithms inside that you can say, hey, anytime you see this kind of thing, that's edgeware and that's important, and we can take a look at that and recognize that, then you can throw in a whole assemblage of 3D scans and say, oh, all these have useware on the edge and all these have, this and that stuff. Once the software can really get to that level, and it sounds like they're trying to get close with this, if not already there in some cases, that's where I think it really comes in, because not everybody is really technologically proficient and capable in seeing that kind of detail in a lithic artifact.
Yeah, well, that's this is going to throw the whole conversation in a different direction, but that's something that is also overlooked in the in this article, is that is useware. They talk about it a couple of times, but only insofar as it obscures the overall shape or some of the facets, some of the scars that are there. Like it's an accident, like useware isn't an important feature of the object. They're really focused on the creation of the object and how that, and analyzing the dimensions and the scars and so on to get a better sense of the creation. But as anybody that does any work with lithics knows, how the objects are used is a critically important part of the life of that artifact. And they kind of gloss over that here. Yeah. Hopefully later iterations of the product are going to be able to do what you were just saying, recognize useware and highlight it, and then, let the specialists try to analyze that. Oh, this looks like it was used for, for skinning hides or for butchering meat or for whatever. But that's not part of this Artifact 3D right now.
Right. So I guess one last question for you then, Paul, as we wrap up this podcast episode is, you've done the Lagash project twice. You've been out there a couple times in the last year, and you're undoubtedly going out there again because the project isn't finished. And now you're going to Saudi Arabia with a different organization. And in both cases, what was the artifact collection? I mean, I know at Lagash you were collecting artifacts, but they're still in Iraq, and I don't think you brought any of those home, right?
No.
Yeah, you guys didn't bring those back. Yeah, and it's probably the same thing with the project you're going on in Saudi Arabia. Do you know if if either had even considered 3D scanning in the field laboratories that might be set up when these artifacts are collected. Is that part of the methodology, or are we not quite there yet for something like that?
We're not quite there yet. I will probably push for introducing that to the Lagash because I'm basically their technologist, and I think that could be a valuable addition to the toolkit.
Mm-hmm.
Probably not going to. I'll be going back in the fall. I'm probably not going to be able to explore that this fall because we're doing different kinds of survey. I still have to finish my surface survey, and we're looking at acquiring some magnetometry equipment so we can do some more geomag survey. The project in Saudi, I don't know what their plans are with 3D scanning. I don't think there are any, but I do know that we're not collecting anything. It's a survey. So just like the work that you do in the Southwest, just like the work I did with you last year in Nevada, it's going to be walking over the landscape and taking pictures and noting GPS points and doing drawings, but not picking up and collecting and taking back to the lab any of the artifacts that we find.
It would be cool to see if, you could get one of these 3D scanning apps to work. And in addition to the stuff they require you to record, maybe 3D scan in the field, a few artifacts that are picked up and just see if there's any usefulness to that, any accuracy to it. You know what I mean? That'd be kind of neat. So.
Yeah, and I've got a few, like I said, I've got a few different 3D scanning apps on my phone, so I might do that informally on my own.
Yeah,
just to see if it works, And if it does, I'll present that back to the people I'm working for, and if they like it, they like it. If they don't, they don't. That's fine. But it gets me a little closer to being able to do that in Lagash, which is my primary project right now.
Well, if anybody would be down for doing it, I know the firm that you're going out there with is probably one of the most tech forward firms in the United States. And if anybody would be down for trying something out like this, it would be them for sure. So that's pretty cool. Yeah. All right. Well, this is the last episode for a few episodes with Paul, because as he said, in a few days, he's headed off to Saudi Arabia. And we are bringing on, though, and hopefully we can get this going. I've been in communication with him, Ed Gonzalez-Tennant, and he has been on the Archaeotech podcast before. And he's very technological in the things he's done. He's got an awesome way of presenting digital humanities and the things that he's doing out to the public and his outreach and things like that. So we're going to bring him on for, I hope, a few episodes as, to talk about what he's doing, but also as potentially a co-host while Paul's gone.
Yeah, I'm excited to have him, filling in my stead while I'm gone, because his work is excellent. Not just the technical work, like he said, but also, as you said, his very human approach to the tech. He tries to look at the work that he's doing from a very anthropological perspective and working with descendant communities and all sorts of really, really thoughtful, good projects. And a big part of what he does is, he's a professor, so he's very into teaching the next generation of archaeologists and computer specialists of various kinds. So his experience is absolutely going to be an invaluable perspective to bring to this podcast while I'm away. And hopefully I can record a little bit when I'm away. We just don't know yet what my schedule is going to be.
Yeah, indeed. All right. Well, thanks everybody for listening, and thanks, Paul, and hope you have a good time over in Saudi Arabia, get a lot of good work done, collect a lot of good data, and hopefully you can record. Yeah. And I guess we'll welcome on Ed next time, and we will see you guys in a couple of weeks.
All right. Take care. Thanks for listening to the Archaeotech podcast. Links to items mentioned on the show are in the show notes at www.archpodnet.com/archaeotech. Contact us at chris@archaeologypodcastnetwork.com and paul@lugal.com. Support the show by becoming a member at archpodnet.com/members. The music is a song called Off-Road and is license free from Apple. Thanks for listening.
This episode was produced by Chris Webster from his RV traveling the United States, Tristan Boyle in Scotland, DigTech LLC, Culturo Media, and the Archaeology Podcast Network, and was edited by Chris Webster.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.archpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.